Okay, in the short demo, I demonstrated how a user would interact with this application. In this video, I'm going to talk about the architecture and the technicals of the application. So the first thing I showed was, well, authentication and serving the application from a CloudFront URL. So what how that works is I exported the client or deployed the client to S3 as static files. And then those static files get served by S3 and CloudFront to users. So CloudFront allows us to have that CDN distribution, and it also serves the client, which is it makes it very easy to deploy. And I also get a HTTPS URL that I can use for this demo. The client will interact with this um, page via different mechanisms. So one of the first features that I showed was creating a new document. So this is going to make a REST call to the page, or the page is going to proxy that REST call to a doc service. And that doc service is going to create that document, persist the document to Postgres. In Postgres, it's going to upload metadata for the document, including the document itself. Media attachments, what it's going to do is it's going to request a pre-signed URL from S3, and it's going to give that pre-signed URL back to the client. So the upload of the pre-signed or of the blob in the media file gets sent from the client directly to S3, and this alleviates some of that traffic that goes through our doc service. As you can see, the doc service is actually already pretty busy, so putting blobs through it is not going to be scalable. The other thing is that you notice that I was making edits to the document, and that worked with WebSocket connection. WebSocket is essentially allowing us to do real time updates to the document that gets published and broadcast to other users that are listening to that same connection. And that gives us the live feedback of someone makes edits, and then you see it almost instantly from the other client. There is a bit of a debounce to not saturate the network with too many requests. Otherwise, each letter that gets typed in would be sent, and this is a little bit more scalable. When a user makes changes to a document, what happens is that doc service will publish the change to a CDC. On top of persisting it to Postgres, it would also publish that change to Kafka CDC, and a CDC worker in ECS is going to pick up that change, mainly around titles and content, and it's going to find keywords, and with those keywords is going to build a reverse index in OpenSearch, which then when you look for key terms, instead of scanning the entire Postgres database for those keywords, which is very slow, you get very quick lookups from the reverse index, and it will give you a list of documents with those keywords very quickly back to the customer. And I demonstrated that feature. The other thing you can do is export PDFs, and this is probably one of the most computationally expensive tasks that I have. What it does is the client will say, I want to export all these documents, and the doc service will publish an event to SQS saying that we had to publish so many. And we have workers, PDF workers, and ECS, which has auto scaling. So, for example, if one PDF worker is tied up, then we get more PDF workers to clear those SQS messages and make sure they don't pile up. The PDF worker is going to process those documents, generate those documents, and it's going to upload the results to S3 as a zip file containing all those PDFs, and then the client can simply download that directly from S3 with a pre-signed URL as opposed to going through all of our infrastructure. Now there's another path I didn't demonstrate in the video, which is the admin routes. So in order for me to provision users, I created an API gateway with some admin API routes, essentially for user provision. This is not a self-register application. You have to be provisioned by an admin, and this is how I'm doing it. It goes through Lambda for authentication. It uses a JWT token. And then now just to deep dive a little bit more into the services that we're using. So here I'm just explaining a little bit what I demonstrated in the videos. And these are the technologies and deep dives of things that I use. So I've been working on this project since the beginning of the semester, essentially. So initially I was using containers. Everything was local. I was using images for Postgres. This is the S3 version of image for Docker. I have my Kafka image, Zookeeper, which is needed by Kafka. My Elasticsearch, I have ElasticMQ, and a way to emulate what the API gateway would look like. And then I also have my PDF worker. So I was doing this and I had this functioning until it was time to migrate it for this final project to AWS. And these are the services. I'm going to start talking about them from the most expensive to the cheapest, or the least expensive. So the most expensive is OpenSearch. This is our reverse index database. Essentially, it gets populated by that CDC worker, which will take those messages from Kafka and build a reverse index. So a reverse index is essentially structured in a way that the key term maps to a list of documents. So when you look for that keyword, you get a list of documents, as opposed to having to scan all the documents to get a list of documents that contain your keyword. One thing to note is that I am using YJS for conflict resolution with edits, since multiple users can be editing a document. So the changes are actually extracted from the YJS encoded events, and that gets populated into OpenSearch. The second most expensive service is actually MSK, which is our Kafka managed service. And this is needed as a message queue. It's managed by AWS as opposed to managing my own Kafka cluster. And this is deployed via Terraform. I tried to make everything deployable via Terraform, just so the entire architecture can be up and running easily. The fault is I have 2 brokers across multiple availability zones. But this is also scalable as well. And this is what that looks like from AWS. I'm going a little bit fast here because there's a lot to cover. This is the RDS. It's a Postgres database. The important thing to note here is that it's containing user information. It's containing export job information, authentication information. And I'm using AWS Secret Manager to have some of those database connection details that I don't want people to have and access freely. I don't want to hard code. I want to be as secure as I'm allowed to be in this time frame. This is what I think is the most interesting service, which is ECS Fargate containers. So I'm using this for both the PDF workers as well as the CDC workers. They can scale up and down depending on usage and resource utilization. So if more PDF messages get queued, then we should be able to scale more workers to clear those messages from the SQS queue quickly and not let them pile up. Similarly, the same for changes to documents. If the CDC is getting overwhelmed, then we just simply create more workers, and we have auto scaling policies in place. And the containers are saved in ECR, so we can just deploy those quickly if needed. This is the EC2. I could have used ECS as well for this, but I wanted to have control of the service. This is what I have my doc service. This is what gets you those pre-signed URLs, what does authentication, it queries other services within AWS, and you can SSH in here. I use it also for debugging. I went in there and ran scripts to populate and seed sample data. So I created hundreds of documents by running scripts directly from here. And yeah, I like having control, so that's what this is for. For Lambda, I'm using Lambda for JWT token verification. And this is mostly used for the admin API routes that I created to populate and provision users into our database. It's pretty simple. The API gateway is essentially a proxy to the Lambda and other services. So it invokes the JWT, and then it routes the calls to the database to provision users. CloudFront is the CDN. This is just CDN distribution, so it distributes those static files from S3 buckets to different regions. Pretty simple configuration that I have. S3 buckets, this is where I'm storing, you can see here, client, which is the JavaScript, HTML stuff. Export, so those are exports from the client. They automatically delete after 7 days, so they don't pile up too much. As well as images, so media and all that stuff that I don't want to have go through the doc service. It gets stored directly in S3, and then I can just reference it within the documents via a URL. And blob storage is what you want for media. You don't want to store that type of stuff in Postgres or whatever. Then I have the SQS, which is surprisingly a lot cheaper than Kafka. I don't know why, but it is cheaper. Probably because this is more of a AWS native service. But I do have a DLQ for messages that keep on failing. And what else is important to know here? There is a 4-day message retention. I mentioned the DLQ. Well, it also autoscales the ECS workers based on how deep or how many messages are in the SQS. But this is essentially what is queuing the messages from the PDF exports. Secret Manager, I use this to store some of those database connection details, open search details, as well as other secrets within the application. Using CloudWatch was very helpful to diagnose a lot of the failures that I was seeing as I was building this. It also is useful for autoscaling. And yeah, that's important for many of my services. The Elastic Container Registry, I'm using this to deploy the images, the Docker images. So the ECS uses this. EC2 needs those images to create those Docker images and containers that I need to run my application. So here's the images that I have in my repository. Lastly, I'm using Terraform. Everything should be deployed via Terraform. That way I can build it up and tear it down quickly. And these are the REST API endpoints that you can call within the application. These are the admins, which are a bit different than most other endpoints in terms of how they get handled. A health check endpoint. We have WebSocket events. This is different than REST because, well, it's WebSocket, but we do have these type of events to propagate changes between document and other. And then this is the client. This is not very important as it relates to AWS. This is just how the application handles the changes. It talks about YJS and some of the document changes and a little bit about what the client is doing, but it's not necessary to know about that for this project. And that's it.